This video will explain exactly what a radian is and how Blender uses them. A radian is simply a measurement between two specific points on a circle. Okay, to understand radians, we need to understand pi. So I'm just going to put a circle on the screen in front of you now. I'm just going to make it a little bit bigger and position it in the centre for you. As such. I'm going to also put a red centre point in the middle. So the centre point here is obviously the middle of the circle. Now if you remember, the point between the centre of the circle and the outer edge here, if I was just to draw this yellow line, that's your radius. It doesn't matter how long that radius is. It could be like a centimetre, it could be a mile, it could be 25 feet, it could be anything. The point of a radian is it takes that straight line and then wraps it around the outer edge. So one of those lines, so if I was to put a green highlighter on it here, so about there, so that's about 1 radian. So that's about approximately the length of that one line wrapped around the edge of the circle. So that's 1 radian. So how many of these radians can fit around a half circle? Now you can fit a second one, a third one, and just a bit of a fourth one. Now this is usually represented by pi, but exactly 3.142 radians. So instead of saying degrees, you're basically saying you can fit 3.1412 radians inside a semicircle. So by extension, if you're going to do a full circle, you'd be able to fit 6.2824 radians inside the circle. So in other words, if I was to get the highlighter again and just carry this on, so that's obviously your 4th full radian, that's your 5th full radian, and that's your 6th radian, and then obviously you got your bit there. So now you can fit 6.2824 radians. That's quite commonly interpreted as 2 pi. So the long and the short of it is, we've taken this radius here and we're trying to figure out how many of these yellow lines will fit around the edge of a circle. So for a half circle, the answer is obviously 3.1412, and the full circle is 6.2824 radians. Okay, I have a chart here from Wikipedia that looks very scary, but it's not, it's very simple. The only two numbers that you need to be bothered about really is the numbers in the middle here, so you've got the degrees that you're most likely going to be used to, and you've got the radians here, which starts at 0 here, so I'll just highlight that. So there's your degrees, and in green I'm going to put the radians. So on both sides it's 0 degrees and 0 radians. So at the centre of the circle here, where the red marker is now, that's your centre point of the circle, and we need to find out where the radian is. So the radius of the circle, again, is just the centre point between the centre point and the circle. So I'm just going to put that in a blue line for you. So about there. Okay, so 1 radian, or one of these blue lines, is here. So in other words, one of these blue lines will fit between this green highlight here and that 1 radian there. Now if you keep going around, you'll get to the 2nd radian here. If you keep going around again, you'll get to your 3rd radian here. And to get to your half circle, you're looking at 3.141 here, or exactly pi radians. Okay, I've simplified the chart a bit here for Blender uses. All you basically need to worry about as far as Blender is concerned is basically where the 0 starts and where it finishes. Now, when you're setting up drivers and working with armatures in Blender, you'll notice it goes around to 180 degrees and then basically it starts counting back down again in the negative direction, which is what you don't want it to do. So when you're setting up drivers in Blender, I'd strongly recommend that you don't set any upper limits beyond 180 degrees. Now Blender, radians and degrees work together in tandem. When you load up the November panel on the keyboard, you obviously got your transformations, you've got the X-ray, Yankee and Zulu rotation values for most objects and bones. So when you put in, say, 90 degrees inside Blender here, What's basically happening is Blender's performing a calculation behind the scenes for how many radians are taking place. So in actual fact, 90 degrees is just shy of 1.6 radians here. So when you look at the driver, so even though you've typed in 90 degrees, when you look at the driver within the driver editor window, you won't see 90, you'll actually see something like 1.58. The same goes for, say, 20 degrees. If you put in 20 degrees in the end panel in Blender and you load it up in the driver editor window, it won't say 20 degrees. It'll say about 0.35. Now, usually in brackets, it does actually give you the degree there. However, Blender is not reading from that number. It's just basically performing another calculation to put it back into degrees for you. So let's just delete the highlights here. Obviously now you've got your bone in the center of the scene here. So let's just make that red so you can see what I'm referring to. So you're obviously now got a bone in your scene and you're looking at it from the top down. So you want to rotate the direction of the bone through 180 degrees. However, you don't know how many of these degrees there are, or rather how many radians. So what you're basically saying to Blender, instead of putting in 180 degrees, or instead of it reading back 180 degrees, it's actually going to read back to you 3.142, because if you're going to, it's just taking the information around the edge of the circle there and performing the calculation that way. Just as a point of note, I'd recommend setting any upper limits in Blender and the driver editor to 180 degrees. Because if you have a look here, where it says 3.1 and it jumps to negative 3.1, what happens is, say if you used to put in 270 degrees as an upper limit and it tries to convert it into a radian number. Essentially what's going on is the calculation is going all the way around the circle as it normally would, and then it carries on. So it reaches 270 degrees there. However, the problem we've got is the driver now reads negative 1.6. That's not going to work. So instead of saying 2.7 degrees, what you're better off doing in most cases is just putting the upper limit at 180 degrees, or even better, something a little bit lower, such as 90 degrees or 20 degrees, but the maximum it should be is 180 degrees, and then extrapolate it. So what do I mean by extrapolating? Okay, so you have your curve, which is a nice straight line at the moment. Now you need to set up a minimum and a maximum values. So at the moment we've set the minimum value to 1. Well, that's going to be the negative 1. And on the opposite side we're going to add another one that just says 1. Now if you don't set up a limit, it will carry on going forever. So what a limit in Blender basically does is it takes this curve and instead of carrying it on going on forever, like that, instead it actually straightens the curve out, so it stays at negative 1 like that instead, and the same at the other end here, where the blue lines I've just put in are. So now, instead of having an infinite line in either direction, you're basically telling Blender to not carry the bone beyond them particular limits. This bit should make a bit more sense in the actual practicalities of doing the vehicle rigs when we get down to them, because we will be setting up a few limits. So just to go back to the chart, just to reiterate the point one last time, all a radian simply is, it's just the distance between point 0, which is here, or rather, if I just click on this, and basically the distance around the edge of the circle here as such. These charts are available as resources, so if you check those, you'll be able to look into them. I'd recommend keeping them stored somewhere as well, because they'll come in handy for these when you need to convert them. I think that's it for this particular video. I shall look forward to seeing you in the next one.